We're going to solve this trig equation using trig identities. So we have 4 sine squared x is equal to 3 tan squared x minus 1. And so the first step is to try and get all of our sines and cosines, or all of our trig ratios to be the same ratio. So we've got sine and tangent, and we want to get rid of both of those. The first thing I'm going to do is take and remove the tan and use tan is equal to sine over cosine. So here we go. So I'm going to leave the 4 sine squared x the same. And this becomes 3 sine squared x over cos squared x minus 1. And now we look at this, or I look at this and I go, oh, I've got a cos squared x in the denominator. That complicates things because I have sine squared x in the numerator. It's a lot easier to get rid of a numerator, to change a numerator and then use the denominator and try to get them the same. But to turn it into, what I'm trying to say is to make it the ratio in the denominator. So remember, we've got our Pythagorean theorem. So a sine squared x is equal to 1 minus cos squared x. So I'm going to replace both of my sine squared x with 1 minus cos squared x. So this becomes 4 times 1 minus cos squared x. That's equal to 3 times 1 minus cos squared x all over cos squared x minus 1. And I know that you're looking at that looks a little more complicated, but at least now all we have is the cosines, which is exactly what we're looking for. Now we can multiply each side of this equation by cos squared x and remove our denominator. So I'm going to multiply both sides of this equation by cos squared x. And you want to be careful when we're doing this that we don't miss anything parts out, and that's because it's a little bit complicated, but it's not bad. So notice we've got cos squared x times 4 times 1 minus cos squared x. That gives us 4, let me go back to the black pen. So we have 4 cos squared x minus 4 cos to the 4th x. And that's not too bad. And this is equal to 3 minus 3 cos squared x. And I apologize, I have a little out of whack here with my pen, but we're going to get that worked out. Cos squared x minus cos squared x. And now I can simplify this left-hand side. I have 3 minus 4 cos squared x, and the right-hand side stays the same. And one of the things that we're going to do here is hopefully you can see this as a quadratic equation. And I'm just going to rewrite it and use a instead of cos x. So this would be like 4a squared minus 4a to the 4th is equal to 3 minus 4a squared. And so you can see there's a quadratic equation here. We're going to move everything to the right-hand side and solve for, see if we can't factor the quadratic. So I add 4a squared and I subtract 3 from both sides. So add 4a squared and subtract 3. That leaves me with 8a squared minus 4a to the fourth minus 3 is equal to 0. Now, I'm just going to rearrange this and make sure that my a to the fourth is a positive, so the sign of everything's changing. I'm going to essentially I'm multiplying both sides by -1, and it doesn't change when we multiply by -0 by -1. So I get 4a to the fourth minus 8a squared plus 3 is equal to 0. Now I'm going to factor this as a quadratic. I have two numbers that I want to get, so I want to multiply to those two numbers and get 12, and I want to add those two numbers and get -8, And so we've got -2 and -6. So we rewrite this as 4a to the fourth minus 2a squared, and I'm going to write this as plus -6a squared plus 3. And we're going to group these. Factoring out 2a squared, I'm left with 2a squared minus 1. I'm going to factor out -3, and that leaves me with 2a squared minus 1 and 0. Continuing our factoring, we have 2a squared minus 3 times 2a squared minus 1 equaling 0. So now I'm going to rewrite this with my cosines, and I just chose to use a instead of cos x because it looks a little more familiar, but all of this work could have been done using just the cosines. So we have 2 cos squared x minus 1 times 2 cos squared x minus 3, and that's all equal to 0. Let me close that bracket here. And finally, we're going to set each of these factors equal to 0. So 2 cos squared x minus 1 equals 0, and 2 cos squared x minus 3 equals 0. Rearrange, we get cos squared x is equal to 1 over 2. Oops. And we have cos squared x is equal to 3 over 2. And at this point, we're going to look to solve these. Here we can see, oh, cos can't equal a number greater than 1, and so there is no solution to this factor. For the other factor, what we get is cos squared. Not sure what's happening to my writing. Oops. So cos squared x. Oops. Sorry about this mess. There we go. Cos x is equal to plus or minus 1 over the square root of 2. So I just square rooted both sides. And I can rewrite this as plus or minus root 2 over 2. And when we go to our unit circle, we'll see that x will equal pi over 4, and it'll equal 3 pi over 4, and because it's plus and minus, it includes all of those 45 degrees. And so just to want to make sure I'm not doing fractions in my head. So here we have 2 pi, so pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. If we were to do it in just that first cycle or circle. So we had 5 pi over 4 and 7 pi over 4. Now, if we're not given a specific domain, we need to write this in its general equation. And what we should notice is that each one of these is an increase of pi over 2. I'm just adding pi over 2 each time. And so I can rewrite this in its general form. X is equal to pi over 4 plus pi n over 2, where n is an integer. And that is the solution to this trig equation.